So almost all the questions, they are similar only, right?
Yes,
Yes
sir.
or no? Except I guess 7.44 and 7.45. I think in both of these questions, you would not. I hope that you would have had problem with the latter parts of the question. So these are the two questions. Okay. So in both of these questions, if you look, there are two parts. Ionization constant of phenol is this much. This is the information. What is the concentration of phenolate ion? 0.05 molar solution of phenol. So this much you can do. Now, what will be its degree of ionization if the solution also has 0.1 molar, 0.1 molar in sodium phenolate? Were you able to calculate this also?
Yes, sir.
Yes. Achha. How did you calculate this? Can you send me the photo, or can you
Yes, sir.
upload it here? Can you upload the assignment here now, or what
No,
will be easier for
did
you?
not take the picture.
Acha, fine. Send it to Nishkar sir then for this question.
Okay, sir.
7.44.
Sensor.
Okay. Double tick. So these type of questions we will discuss today. Okay. What will happen if I add two different chemical species in a solution? Okay. So I have got it. Wait a second. Hello, Atif, Mohammed, Chef, and Rishan. How are you guys?
Fine. So should we do this question?
नहीं, ये तो होमवर्क था. होमवर्क नहीं किया लगता आपने फिर. This was homework. Okay, I understand this. Okay. Fine. अच्छा. So similarly, you can do the next question also, right?
Sir, I couldn't figure out what was going on in the question.
In the next question, right?
Yes, sir. 4 or 5.
Okay. First ionization constant of H2S is this much. So you are having problem with this word, first ionization constant, Mariam?
Yes, sir.
Okay, fine. So that is not what we have not learned about that. but it is just as the ionization constant. Okay, calculate the concentration of SH negative ion in its 0.1 molar solution. So you could have just taken this as K, ionization constant of the reaction. Okay, where you are getting SH negative, and how will the concentration be affected if the solution is 0.1 molar in HCl also? So this is kind of similar question, right? Because here you have sodium phenolate. So common ion effect will be there. Have you learned common ion effect? Like from school or somewhere? No.
Sir, I think we started it.
Acha, okay, fine. So let me come to the common ion effect, and let me also discuss this word actually, the first ionization constant, and then we can start doing the question 7.44 and 7.45 also. But first, all of you have to do the question that I'm going to give you. Two simple questions. Yeah, write this down. Yes. So can you please turn the mic on, all of you, and tell me for the first one, which of the following will have higher pH? Yes. Atif, Aisha, Rishan, Abhinav, Mariam, Surat.
Am I audible, sir?
Sorry.
I meant to say that am I audible?
Yeah, you're audible. You give me the answer. Which of the following solution will have higher pH? You don't have to calculate pH. You just need to compare it. I hope you can compare. No one? Mariam, Surat. Yes, Aisha.
0.1 mmOH.
0.1 molar NOH. What about others? What do you guys think? Atif, Abhinav, Mariam, Mohammed Sheikh, Surat. No idea? Please tell
0.1
me.
molar.
What about others?
Sir, 0.01.
Arey, nahi. So, what about others? Please tell me. I need a reason then. Okay, now if you are changing the answers, I need a reason because there are only
No,
two things. I need a
sir,
reason now.
actually I did something wrong. That's why I said the wrong answer. Promise.
Yes, Mariam, Surat.
Sir, not sure. 0.1.
Not sure why. How are you evaluating this question? Tell me.
Sir, I'm not evaluating, just comparing.
Again, how are you comparing? Tell me.
Sir, 0.1 is greater than 0.01.
Yeah, and that is why it will give me more OH negative ions, right? So basically, what they are asking, which one is more basic? Anna? If I can compare the basicity, that means if someone is more basic, it will have higher pH. Okay. So tell me which will be more basic. This is more in concentration now than 0.01, and that is why 0.1 molar NaOH is more basics, and hence it will have a higher pH. Now, if I compare here, then which of them is more basic? Tell me 0.1 molar HCl or 0.01 molar HCl?
0.1.
molar.
Which is more basic? 0.1 मोल है।
0.01.
हाँ, ये 1 मार्क्स से सवाल में गलती मत कीजिएगा क्वाड्रेटिक इक्वेशन से आके, समझे? सिंपल क्वेश्चंस ना, you just have to compare these things. That which one of them is more basic? Please, higher pH, more basic, or lesser acidic. Now you compare here, which is more basic, HCl or NaOH?
NaOH.
0.1 molar NaOH. Now you compare here, which of them is more basic or less acidic? है ना? More basic means less acidic. Tell me.
CS3COH.
0.1 CH3.
Yeah, CS3COH, correct. What about here, which is more basic or less acidic?
NaCl.
NaCl, correct. बाकियों को आया कि नहीं आया? सूरत, why I am not hearing anything from you? Abhinav, Aisha, also you have stopped and you are giving me wrong answers, Aisha, initially.
Sir, actually, my mic was getting stuck. That's I was trying to say for so long. Sometimes it will be okay, and sometimes I don't know something will happen.
Acha.
And so, like I just guessed the 0. Like that's the first answer. I just guessed it and said you. Then later I felt like it will be 0.01.
हाँ, तो you are just guessing, है ना? So that is not a good indication.
No,
ना?
I was sure about 0.1. Then I thought that
हाँ,
it
तो
can
why,
be
how?
0.01.
I am asking why. So you have to answer me. The basic, more basic means more pH value. Please understand the concept. Don't keep guessing, or don't be confirm about a particular answer just to feel like that. You should have a reason, okay?
Okay, sir.
Now, right, calculate the pH of 1 into 10 to the power minus 8 molar HCl solution. Answer, send the answer in chat, okay? Yes, Mariam, correct. But something seems wrong, right, Mariam?
Yes, sir.
I'm very glad that you stopped there. Okay. We will see what is happening and why it is not right. I'm waiting for others. Calculate the pH of a solution which has 1 into 10 to the power minus 8 molar HCl. Aisha, can you send me the answer? Can you send the answer to Nishkash, sir? Aisha, can you hear me? Okay, fine. We will see. We will see. What about others, huh? Atif, Surat. Why I'm not getting any answers? Yes, Atif? Yes, Atif.
Yes, sir.
What happened? No idea how to calculate this?
Yes, sir, not sure.
Not sure. Why? You were not present in the previous class.
Yes, sir, I was there.
So you did not do any question from the assignment. Yes, I mean, in the last class we did questions now on this. This is the simplest question that you can get on PH. Atif, please answer me. What happened? Did you not do any question?
We did, sir.
So see this question. Calculate the pH of a solution containing this many hydronium ion. And we also did calculate the concentration of a particular solution containing CaOH whole twice. Then we calculate the concentration of CaOH whole twice. Then we wrote the reaction, and then we calculated the concentration of OH negative, H positive. So we have done, like, I can say, lengthier questions than this. Okay. So see, so when we start this question, we first of all, whenever we get to calculate the concentration or we have to calculate the pH of a particular solution, then we look whether this acid or a base, whatever electrolyte has been given, is strong or is it weak? So since it is strong, HCl is strong, then what do we write? That the concentration of, we write the reaction like this, is in equilibrium with H plus Cl negative, and 1 mole of HCl is going to give me 1 mole of H positive, and hence we say that the concentration of HCl is going to be equal to the concentration of H positive. Okay, it's going to be equal to the concentration of H positive. Now this is all fine when you have a strong acid. But if you look at this question and if you start calculating the pH, which is equal to minus log of H plus, then you will be getting minus log of 10 to the power minus 8, which will be equal to, pH is equal to minus of minus 8, right? Because 8 will come down, log 10 is equal to 1, and this will be equal to 8. Now, I hope all of you can see that this can never be a right answer, because when we have an acidic solution, the pH should be at least less than 7. It cannot be more than 7. It can never be more than 7. So what is happening here and why it is getting wrong? So when I write the concentration of H plus is solely equal to HCl, that is not completely correct. Because there are two reactions in a solution. When we have aqueous medium, then there are two reactions which are giving me H plus ion. So this HCl is also giving me H plus ion, and we have water molecules which is also giving me H plus ion plus OH negative ions, right? Now, in this case, for HCl, the concentration of H plus is how much? The concentration of H plus is 10 to the power minus 8 molar. And here the concentration of H plus is how much? 10 to the power minus 7. Now, when we have comparable concentration of both the H plus from H2O also and from HCl also, then we have to take in consideration the H plus from water. But usually, when we have a strong acid and it is a concentrated acid, the concentrated acid has a very high concentration of H plus, and relative to that, the concentration of H2 is not very much. The concentration of H2O is not very high. So we ignore the concentration of H positive and we just say that the concentration of H plus is only equal to the concentration of HCl. That is a strong acid. That is a strong acid. But in this case, we have to take into consideration the H plus also. The H plus also. So for this type of cases, you have to note that if you have molarity of, if the molarity of the solution is equal to or less than 10 to the power minus 6, so right, if molarity of solution is equal to or less than 10 to the power minus 6 molar, then H plus and OH negative from water is considered. Okay, then it is going to be so in this case we are going to consider the concentration of acid, concentration of H plus that we are getting from water also, Now you also have to remember when we have these two reactions now, when we have, this is the primary reaction, I can say that we have two reactions. H2O is going to give me H plus plus OH negative, and in this case the concentration of H plus that I'm getting, it is equal to how much? It is equal to 10 to the power minus 7, and it is equal to 10 to the power minus 7, and this is 10 to the power minus 7. And if I'm using HCl, then I'm getting H plus plus OH negative, and the concentration that I'm getting from H plus here, it is 10 to the power minus 8. So which is small, which is larger in this case is the first reaction is larger, second reaction it has smaller concentration of H plus, and that is why this will be our primary reaction. Okay, this is the primary reaction. Now we have water in which we have H positive and OH negative. H positive is 10 to the power minus 7 molar, and then I am adding to it 10 to the power minus 8 molar of 10 to the power minus 8 molar of H plus ions. Right, guys? I'm adding 10 to the power minus 8 molars of H plus ions. So what I'm doing, I'm adding something from the product. I'm adding something to the product. Now, if the human is adding something to the product, then what will happen? The equilibrium will shift backwards or forwards. What will happen to the reaction?
Backward.
Yeah, it will shift backwards. Okay, so it is going to shift backwards. Now, all of you remember. Now let us just end this. Our primary, we will be taking the primary reaction only. Okay, we will be taking the primary reaction only. Now, after we have added the HCl, I can write the reaction as H2O. It is in equilibrium with, there is a concentration of H positive plus concentration of OH negative, right? The concentration of H positive is how much? 10 to the power minus 7 plus 10 to the power minus 8. Okay. And the concentration of OH negative is 10 to the power minus 7 only, because we have not done anything to the, sorry, यहाँ पे हमने OH negative लिख दिया. Here it should be Cl negative. Fine. Right. So can I write like this after I have added HCl, that the concentration of H plus is 10 to the power minus 7 from H2O and 10 to the power minus 8 from the HCl. Can I write it like this? Yes or no? Tell me.
Yes, sir.
So this is the initial after we have added HCl. So what is going to happen if I have the concentration like this? So now you can do, if you add these two, how are you going to add these two? So 10 to the power minus 7 and this is 10 to the power minus 8. So 10 to the power minus 7, you will write it like this, plus you can write 0.1 into 10 to the power minus 7. And this will be equal to how much? 1.1, because if you take the 10 to the power minus 7 common, करके ही बता देते हैं आप लोग को. No one has problem till here. 10 to the power minus 7 plus 10 to the power minus 8 is equal to 10 to the power minus 7 plus 0.1 into 10 to the power minus 7. Tell me, guys, no problem now?
Yes, sir.
Yes, sir.
I hope you guys have no problem, because 10 to the power minus 1 is 0.1 only. Okay. So 10 to the power minus 7 will be common. So 1 plus 0.1 into 10 to the power minus 7, which will be equal to 1.1 into 10 to the power minus 7. Correct? Right? Yes or no? Tell me.
Yes, sir.
Yes, sir.
Right. Okay. So what I'm doing, I'm just erasing this and just writing directly. The concentration of H plus is 1.1 into 10 to the power minus 7. Now, in this case, the Q will be equal to, because this is not equilibrium, we have just started, this is not equilibrium. Then what is going to happen? 1.1 into 10 to the power minus 7 into 10 to the power minus 7, which will be equal to 1.1 into 10 to the power minus 14, correct? And what is the K? This is what? This is greater than K, na? That is 10 to the power minus 14 for water. Kw is how much? 10 to the power minus 14. So this should be the concentration. This should be the product of the concentration of H plus and OH negative, no matter what. But right now we have the product that is greater than 10 to the power minus 14, that is Kw. Yes or no? Tell me, guys.
Yes, sir.
Okay, so now here also from this qualitative analysis also we can say that the reaction is going to move backwards, correct? Correct? Yes or
Yes, sir.
no? Okay. Now there are two ways. There are two ways for solving this type of, and to get what will be the equilibrium concentration. Okay, what will be the equilibrium concentration? Now see, what you can do, you can write that there will be minus X, right? Because it is going to react. We are going backwards. Right? So H plus is going to associate with OH negative. So some of the H plus will be getting associated. So minus X, there will be a decrease in concentration of H plus and minus X here. Okay, then you are going to write it as 1.1 into 10 to the power minus 7 minus X into minus X, right? Into minus X, yes or no? And then what you can write? You can write about Kw. Kw, it is equal to 1.1 because the concentration of H plus. Kw is equal to how much? Concentration of H plus into concentration of OH negative. Okay, and then you can calculate 1.1 into 10 to the power minus 7 minus X, and into X into minus X. So you will get a quadratic equation, and then you have to solve the quadratic equation. Yes or no, guys? Tell me.
Yes, sir.
Okay, fine.
Yes,
But
sir.
there is something that you can use, like intuition kind of thing that you can use. So this is only applicable if you are dealing with one side of the reaction, because we don't have to consider H2O, we don't have to consider H2O. Why? Because H2O is a liquid. So whenever you have this type of case, you can use your intuitive mind. And I'm writing a very simple case here. I'm writing a very simple case. Let us suppose I had A and B, and they were going backwards. Okay. And the K here was equal to, let us say the K here was equal to 10. The K was equal to 10. Now, K was equal to 10. And we had here, let us suppose we had, it will be easier if I take 1. Okay. So just let me take 1 here. K was equal to 1. Okay. So in this case, we have A plus B, and the concentration of A, it is equal to, let us say 5. Okay. And the concentration of, let me say like this. So initially, initially they both had 3. So I added 2 moles of A. To it, and none moles of B. So starting mein kya ho gaya? Now we have 5 and we have here 3. Correct? Okay. Now,
Yes, sir.
by this simple equation, you can see that if I react 1, yes or no, what will happen? How much should I react from 5 to get it equal to 3? How should I react this? Tell me. How should I react this to make both of the things equal? How should I react? We have 5 moles of A and 3 moles of B. Wait a second. This is not right. Wait a second. Wait a second. Let me give you some different, because 3 maybe though it will not be equal to 1. Na? 3 maybe it will not be equal to 1. Okay. 1 ही रहेगा. So A plus B. Okay. Here you have initially you have 2, and here you have 1/2. Okay. These are the concentration. No, it has to be equal. So 1 लेके चलना पड़ेगा, I think. 1 लेके चलना पड़ेगा. 1 and 1. So I added 2 here, but again I have to get it to 1, both the concentration. So one should be higher and one should be lower. That is fine with me. That is fine with me. Okay, K is equal to 1. So now you tell me, which question are you solving? This question, calculate pH of 10 to the power minus 8 molar HCl solution. Okay. Okay. So I added plus 1 molar here. So I have 2 moles of A and 1 mole of B. We have 2 moles of A and 1 mole of B. Now you guys tell me, how much should we react? How much should we react? From A and B to make both of them equal. Not equal, but the K should be equal to 1. The product of these two should be equal to 1.
1.
1. But if I react, so if I do -1 here and -1 here, it will B will become 0. How should I do this then? Am I not taking a good example? I can take this example in water, but I need. Okay, let me take this example in water and let us try this in water only. So we have H positive plus OH negative. Okay. So initially this both of them were 10 to the power minus 7. This was also 10 to the power minus 7. And now it is how much? This is 1.1 into 10 to the power minus 7. And OH negative is just 10 to the power minus 7. So we have added 0.1 into 10 to the power minus 7 molar H plus ion. Yes or no? Tell me. It was both of them initially. When we don't add any HCl, it was 1 and 1. Now when we added HCl, that means we are adding 0.1 into 10 to the power minus 7 H plus ions. And now we have 1.1 into 10 to the power minus 7 and 10 to the power minus 7 OH negative ions. Just look at this and tell me now if you're okay with all these numbers. And this is
Yes,
how much
sir.
we have added. Yes. Okay, fine. Now we need to maintain 10 to the power minus 14. Correct? Yes or no? We have to
Yes, sir.
maintain 10 to the power minus 14. Okay. Now, if I react half of what I have added, if I react half of whatever I have added here and the react same amount here and react the same amount here. So what I'm going to do, I'm going to react in this case minus 0.05 into 10 to the power minus 7 and here also minus 0.05 into 10 to the power minus 7. Okay. So in both the cases, what I am doing, so since I have added 0.1, and I added 0.1, but when I am removing when I have to remove 0.1, I have to remove it like I have to distribute like half of the moles I will be removing from H plus and half from OH negative, and this will be equal to 0.1 whatever I have added, whatever I have added. Okay, so please see this if it makes sense to you. Otherwise, you can go to quadratic equation. That is perfectly fine. No one will cut marks for that also. Look at this if you are okay with just estimating that it will be 0.05. Tell me. No. No one. Atif, Mariam, anyone? Acha, okay, fine. Let us go back to the quadratic equation. Okay, so we can solve the quadratic equation. So we have this. This will be equal to kw, which is equal to 10 to the power minus 14. है ना? So you have to solve for x. If you are not okay with that, don't worry. जरूरी नहीं. Calculate this now. Calculate the x here. Wait a second. This is going to be, wait a second. This is 10 to the power minus 7 minus x, not x. My bad. I have written there, but I did not add these 10 to the power minus 7. Yeah. Tell me if you get x. Okay, I hope you guys are calculating. Mariam, Atif.
Yes, sir.
Yes, guys. Anyone? How much is the X? Oh, what happened, guys? No one has got the answer till now. Oh, guys, what happened? Aisha, you have solved this, na? Yes, Aisha. Okay, what happened? Aisha is also not answering now. Yeah, no one is getting that. Miss Mariam, are you near any answer?
No, sir.
What happened? Why? Acha, okay, we have like wasted a lot of time. So let me just tell you. This is going to be the concentration that is going to change here, okay? Ten to the power minus 7, but it will be 0.05 into 10 to the power minus 7, okay? Because there will be some mistakes in the approximation. So what you will be getting is that the concentration of H plus and the concentration of OH negative, right? So concentration of H plus was how much? 1.1 into 10 to the power minus 7. OH negative was 10 to the power minus 7. And both of them 0.05 into 10 to the power minus 7 will react. Here also 0.05 into 10 to the power minus 7 will react. And you will be getting here 1.05 into 10 to the power minus 7. That is the concentration of H plus. And you will be getting here how much? This is 1 and 2. So this will be 0.95 into 10 to the power minus 7. Yes or no? These are the concentration of H plus and OH negative that you will be getting after after the reaction. Tell me. And the way I use this is that initially I had 1 into 10 to the power minus 7. Then I added 0.1 and I added 0.1 into 10 to the power minus 7. So I just halved this value and I divided both of them into H plus and OH negative. Since this value is very low, this value is very low, 0.01 into 10 to the power minus 7. It is not going to affect the product if I just divide it into both of these terms, H plus and OH negative. And that is why I approximated it to 0.05 into 10 to the power minus 7. Now, further moving on, we have now the concentration of H plus, right? The concentration of H plus is how much? 1.05 into 10 to the power minus 7. Now you can calculate the log. If you put the log here, so this will be log of, or rather minus log, if you want to get the pH, na? Minus log of 105 into 10 to the power minus 9. Because we only need whole number. This will be equal to minus log of 105 is how much? 15. 15 we can write as 5 into 3. So 5 into 3 into 7 plus log of 10 to the power minus 9 will be equal to minus 9 into log 10. Log 10 is equal to 1. Now this will be equal to minus of log 5 plus log 3 plus log 7. Log 5 is 0.7 plus log 3 is how much? 0.48 plus log 7 is how much? 0.84 minus 9. Okay, calculate this much and tell me what is the pH. 0.84 plus 0.7 plus 0. Achha, 8 a second. 48, 84, 4884 0.7 minus 9. Calculate this and tell me what is the answer. I think you will get minus 6.98, which will be equal to pH is equal to how much? You got the same answer? Yes, anyone,
Yes, sir.
Mariam? Yeah. Okay, so pH is 6.98. So if you're writing, write this down completely. Let me know if you're done.
Answer.
All of you done? Done, guys? Okay, fine. So let me move on. Now I have to give you a relationship between a few things. So please just write relationship between pH and pOH, pH and pOH of a particular solution. So we are basically comparing the concentration of H positive and concentration of OH negative and the minus log of both of them. So we know that the concentration of H positive and the concentration of OH negative in any solution, it is equal to 10 to the power minus 14, no matter what, whether it is acidic or basic. The concentration of these two things should be equal to 10 to the power minus 14. Now I am putting log on both sides and write this with me. This will be equal to 10 log into 10 to the power minus 14. Now what will happen? I can write this as log of concentration of H positive into, plus log of concentration of OH negative. Concentration of OH negative, which will be equal to 10 to the power minus 14. And log of 10 to the power minus 14. And then this minus 14 will come down. It will become minus 14. If I multiply the whole equation with minus 1, I can write this as minus log of H positive plus minus log of OH negative. This will be equal to 14. So minus log of H positive, it is pH, minus log of OH negative, pOH. This is equal to 14. So write this down.
Answer.
Done, all of you? Is there anyone who is still writing? Atif, Muhammad Umar, anyone? No? Okay. So if you have the pH, you can calculate the pOH also, okay? And vice versa. Right, next. Relationship between Ka and Kb of conjugate acid base pair. Conjugate acid base pair. So for example, let us take an acid that is Ha. Let us take an acid that is Ha. So the acid Ha plus H2O, you know that it is going to give me H3O positive plus A negative, right? Now in this case, this is the acid and this is the base, and that is the conjugate base. Okay, we can also write these are the conjugate acid base pairs. So I'm just writing base here, right? Because this is a pair. Now for this reaction, I can write the Ka, because in the reactant side we have acid, and acid is something that is reacting with water, and so we have to write Ka. So Ka will be equal to the concentration of H3O positive into the concentration of A negative divided by the concentration of Ha, right? Because we don't write the not H2O. We don't have to write H2O because it is a pure liquid. We don't write the concentration of pure liquid. So next, this is for acid. What can happen? This base A negative, it can also react with A negative plus H2O, can give me, it will abstract one of the hydrogens from H2O and it will get Ha. It will become Ha, and H2O will be left with OH negative. H2O will be left with OH negative, right? Now in this case, I will write the Kb because this is acting as base. This is acting as base, and this is the acid, right? This is the acid. Now the Kb for this reaction will be equal to the concentration of Ha. Let me just get this a bit down, right? So Kb will be equal to concentration of Ha into the concentration of OH negative, right? Concentration of Ha on concentration of OH negative divided by the concentration of A negative, right? Concentration of A negative. So this is the Ka and this is the Kb for conjugate acid base pair. So if I multiply these two things, Ka into Kb, Ka into Kb. So this will be equal to the concentration of H3O positive into A negative for Ka divided by Ha. This is for Ka into Kb is how much? Kb is Ha into OH negative divided by A negative. I hope you can see that we can cancel a few things. I can cancel Ha and Ha. I can also cancel A negative and A negative, and this will lead to Ka into Kb of conjugate acid base pair. This is equal to concentration of H3O positive into the concentration of OH negative. And what is this? This is nothing but this is Kw. So the product of Ka and Kb, it is equal to Kw, which is equal to 10 to the power minus 14, which is equal to 10 to the power minus 14. Achha, we can also extrapolate this again. So what I can do, I can write the log. So log of Ka into Kb of conjugate acid base pairs. Okay, conjugate acid base pairs. As an like you start with any acid or any base, there should be the pair, conjugate acid base pair, Ka and Kb, both of them. Okay, not all acid and all base, but the conjugate acid base pair, Ka into Kb. This is equal to log of 10 to the power minus 14. I hope I can skip some, because you can see minus 14 will come down. It is the same thing that happened here, right? H log of H plus into OH negative, it is equal to 10 to the power minus 14. And here we have log of K into Kb, it is equal to 10 to the power minus 14. And hence I can directly write pKn pKa plus pKb of conjugate acid base pair, it is equal to 14. Okay, so this is the second relationship that you have to remember. So these are simple relationships. Write this down. Let me know if you're done. This thing is important. The most important thing is that don't forget this. Okay, guys. This is only valid for conjugate acid base pair. Hai na? That means if I have CH3, COOH, and I have CH3, COO negative plus H positive, right? In this case, this is the acid, and this is the conjugate base. So this is the pair. This is the pair. So the Ka of CH3, COOH, and the Kb of CH3, COO negative, right? So we are writing the relationship between like these type of species. Write this down. I will give you a question, then we can understand better.
Sir, could you show the heading of the previous equation?
A relationship between pH and POH. Relationship between pH and POH. This is for solution, any solution, okay? pH and POH. That means the concentration of H plus in a solution and OH negative. What is the relationship between that? pH is nothing but it is easy way of, or rather I should say, it's a layman term for concentration, pH. That makes things easy for general mass. pH and POH. You write this down. Let me know if you're done.
Done, sir.
All of you done?
Done.
Done. Okay. So just let me give you a question. Write the question. calculate the ionization constant. Ionization constant of conjugate acid of ammonia. Okay, of ammonia. Okay, if ionization constant of ammonia is, if ionization constant of ammonia is 1.7, or rather I should write 1.77, I think it is 1.77 into 10 to the power minus 5. 77 into 10 to the power minus 5. How many of you have this urge to write the answer that the ionization constant of conjugate acid of ammonia will be this much only, or something related to that without doing any calculation? Never write like this. It will be equal to 1.77 into 10 to the power minus 5, or 1.77 into 10 to the power plus 5. And ऐसा नहीं होगा, please remember, okay? At least these are not the answers. So we have, see, the important thing is that you read the question carefully. Calculate the ionization constant of conjugate acid of ammonia if ionization constant of ammonia is given. That means I have to first of all see what is the conjugate acid of ammonia. है ना? So NH3, I will react this with water, and NH3, it has a lone pair. It will abstract one of the protons from hydrogen, one of the protons from water, and it will give me NH4 positive plus OH negative. Plus OH negative. Now this is acting as a base. This is ammonia. It is acting as a base, and this is its conjugate acid, right? This is its conjugate acid. So we know that for base I am going to write Kb, and for acid I'm going to write Ka. And since they are acid-base pair, I can say that Ka and Kb, the product, it is equal to how much? Tell me, 10 to the power minus 14. Ka into Kb, it is equal to 10 to the power minus 14. And we can directly write now that we have to tell the conjugate acid now, yeah, of ammonia. So Ka will be equal to 10 to the power minus 14 divided by 1.77 into 10 to the power minus 5. So this will be equal to 1 upon 1.77 into 10 to the power minus 9, right? Yeah, minus 9.
Sir,
Yeah, tell me.
sir, why would it be 1.77 into 10 raised to positive 5 or negative 5?
It will not be. I was saying that, like, some student, they have this urge now that they don't read the question carefully, that calculate ionization constant of conjugate acid of ammonia if ionization constant of ammonia is 1.7 into 10 to the power minus 5. So many students, they have in this in their head that if it is opposite, then it will be either reciprocal, or it will be either जो minus है वो plus हो जाएगा, जो ऊपर जो numerator में वो denominator में हो जाएगा. So some of them have those kind of mindsets. So I'm saying that it is never like that. Okay, so if anyone's mind is telling that it should be reciprocal or it should be positive or negative हो जाएगा, then it is not the case. Okay, Mariam, you got
Yes,
it?
sir.
हाँ, ऐसा होता है ना कभी कभी, like you feel it should happen like this, but it is not like that. So write this down. So these are very simple 1 marks question that you can have, but these are important relationships. Okay, important relationships.
And sir.
Done, all of you? All of you done? Yes or no?
Yes, sir.
Yes. Okay. Now, right. Polyprotic acids, right? Polyprotic acid. Okay. Polyprotic acids means the acids that can give more than one H plus ion. So if you have an acid which has only one ionizable hydrogen is known as monobasic or monoprotic. Okay, monobasic basic mean it can handle 1 moles of base. Okay, monobasic. If you have two ionizable hydrogen, IH is ionizable hydrogen. Okay, IH is ionizable hydrogen, then it will be dibasic. If you have 3 ionizable hydrogen, then it will be tribasic. Okay, and so on. And it will be tribasic and so on. So one of the example that I will start with is the example of H2CO3. Okay, so if I have H2CO3, then it is going to give me H plus ion plus HCO3 negative. Okay, HCO3 negative. Now I can see that if I write the Ka for this reaction of acid, then I can write it as the concentration of H positive into the concentration of HCO3 negative divided by the concentration of H2CO3. Okay, now next I can see that here this hydrogen is also ionizable. We have another hydrogen, so I will write HCO3 negative can give me H positive plus CO3 2 negative plus CO3 2 negative, and the Ka for this reaction, so I will write this as Ka1 and let me write this as Ka2. For this reaction will be again the concentration of H positive into the concentration of CO3 2 negative divided by the concentration of HCO3 negative. Okay, this is Ka1, this is Ka2. Now if I add the reactions, both of these reactions, if I add it, then I can say that this and this can get cancelled, and I will just get H2CO3, which is in equilibrium with 2 moles of H plus 1 mole of CO3 2 negative. Now if I want to write the Ka for this reaction, this will be the final case Ka, that is the main Ka. It will be equal to the concentration of H positive squared into concentration of CO3 2 negative divided by the concentration of H2CO3. Now if I look at the relationship between Ka and K1 and K2, then obviously it is not an addition reaction. It will be, they are multiplicative, they are not additive. That means equilibrium constant, they are multiplicative. If I have Ka1 into Ka2, then you can see this, that it is H plus into the concentration of, this is for Ka1, HCO3 negative divided by H2CO3, right, into Ka2 is how much? H plus into CO3 2 negative divided by HCO3 negative. Here also we can cancel this term and this term, and the final term will be similar to Ka. We'll have H positive, the concentration of H positive into H positive. We have 2 H positive, that is why this will be squared into CO3 2 negative divided by H2CO3. So for H2CO3 I can say, for H2CO3 I can say that Ka1 into Ka2, it is equal to the original Ka, that is the ionization constant. That is the ionization constant. Okay. Next is, in general I can say Ka1 into Ka2 into Ka3 dot 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 is equal to the dissociation constant of the acid. Now this is known as the first dissociation, because we are dissociating first dissociation. This is known as the second dissociation, and the constant that corresponds to first dissociation, Ka1, it is known as the first dissociation constant, and the second one is known as the second dissociation constant. So write this down, let me know if you're done.
Done, sir.
What about others? Done, guys? Yes, Atif, Umar, Surat, Najib, guys, done.
Sir.
Okay. Acha. Now, think about which of the dissociation will be easy, the first or the second one? Which will be easier? Tell me. Which will be easier? You think about it like this: you have a neutral species and you're taking out a positive ion from a neutral species. Okay, so you have in the neutral species same number of positive things and same number of negative things, and you are taking one of the positive things, that is H plus. In the second dissociation, in HCO3 negative, you have more negative charges, right? So they will be holding the H positive more carefully and more effectively than the previous case, because you have negative charge and negative charge has the affinity towards positive charge. So the second dissociation will be slightly difficult, not slightly, but largely difficult from the first dissociation. And hence, we will get more H plus ion from the first dissociation than the second dissociation. So I can say Ka1 is greater than Ka2 and so on. And also we can write Ka1 is the highest, followed by Ka2, followed by Ka3, and followed by so on, right? Followed by so on. And also write one more point in as a statement, that the acidic strength of polyprotic acid acids decreases as protons are lost. Okay, so write these two lines. Let me know if you're done. Then you will look at the acidic strength. Okay, then you will look at acidic strength. Done, guys? Yes, done or no?
Done, sir.
Done. Okay. Okay. Right, next. Next, right? Acidic strength. So for acid, we have HA, which is going to give me, all the acids are going to give me H positive. Okay. So in your syllabus, whatever you are learning, if you ever have to compare the acidic strength, then you have to, this should be always a, there will be a acid which give H plus ions into water, and a conjugate base that is A negative, and a conjugate base that is A negative. So all the acids are going to give you H positive. The only thing that is going to differ is the A negative part, right? If I compare HF, HCl, HBr, and HI. So if I have to compare the acidic strength of these things, then I have to see H plus is the same, right? And A negative is something that will be different. the conjugate base is going to be different. Okay. Now we know that if we have more number of products, if the number of product is more, the concentration of product is more, that means the stronger is the acid, right? We will have strong acids. That means we should have more number of H positive and more number of A negative, and the bond breaking between H and A, it should be easier, right? HA bond should break very easily. Now there are multiple factors that affect the bond breaking of HA, that affects the bond breaking of HA. Also, one more thing is that after the bond breaking of HA, this A negative should be stable, right? If the A negative is stable, that means it can easily dissociate from H positive. It can easily dissociate from hydrogen and it can form A positive, sorry, A negative. So the conditions are this acidic strength, I can say acidic strength, I can say it is, first of all, inversely proportional to the HA bond strength, right? If the bond is weak, that means the acid will be strong, right? If the bond strength is very low, acidic strength will be high because it can easily dissociate. Also, I can say it is directly proportional to the stability of conjugate base, that is A negative. Whatever conjugate base you are getting, A negative, it is directly proportional to the stability, because if it is stable, then it can easily go and it can easily form product and we will get more and more A negative. And if we want to get A negative, then there will be obviously H positive and acidic strength will be higher. Acidic strength will be higher. So we will be comparing the hydro acids only. First of all, we will be comparing hydro acids. Hydro acids are something which have hydrogen attached to the central atom. Okay, hydrogen attached to central atom directly. Now we will just start write a question, right? Compare the acidic strength of CH4, NH3, H2O, and HF. So first thing is that you can see these central atoms, they have, the central atom, they have hydrogen attached to it. They have hydrogens attached to it, obviously. Now, you can also see that these all are in the same period. Okay, these all are in the same period, that is the second period. Now, in second period, all of the bond strength will be somewhat similar, right? The bond strength will be somewhat similar. But then we have to look at the stability of conjugate base. The conjugate base that I will be getting from CH4 negative, NH3, H2O, and HF. So minus H plus in all of them. I will remove H plus ion from all of them and make the conjugate base. So this will be CH3 negative. This will be NH2 negative, OH negative, and F negative. Right, guys? Tell me. No problem.
Yes, sir.
No problem till here. Okay. Now, as you can see, which has the ability to hold electron most effectively? Which will have the ability to hold electron most effectively? The most electronegative element right now. So F negative can easily hold electrons because it is very electronegative. It is very electronegative. You can also compare this. Because all of them have one negative charge. Carbon has how many protons? 6 protons. Nitrogen has how many protons? 7 protons. Oxygen has 8 protons, and fluorine has 9 protons. So you can also see that 6 protons and how many electrons are there? We have one extra electron, right? One extra electron everywhere. So 6 and 1, it's 7 and 1, 8 and 1. So the interaction will be higher if you have more protons and more nuclear charge, and there is one electron. So this plus 9 can easily attract this electron, right? That is giving you minus charge. Okay. You can see that if I go this way, the electronegativity increases. Negativity increases, and what happens? And stability increases. So that is why the acidic strength will be CH4 will be the least acidic, followed by NH3, followed by NH3, followed by H2O, followed by HF, followed by HF. HF will be the most acidic. You can also compare between pH3, what is after phosphorus, sulfur, H2S, and also HCl. So in this case also, if I go rightwards, then the electronegativity is increasing, and hence the acidic strength will be like this. Okay. So write this down. Let me know if you're done. Now we will compare in a group. We have compared in a period. We will compare in a group.
Done, sir.
Sir, can you scroll up?
Yeah, sure. More?
Yes, sir. Okay, sir, can scroll down.
Compare acidic strength of okay. Done. So in group there will be different thing. Okay. In group we will have different case. In group we will have a different case. Because two things will happen. The bond length will increase of HF and HCl and HBr and HI. That means the breaking of bond will be easier. We can easily break a bond. Write this question and let me know if you're done. Okay. Done, guys?
Yes, sir.
All of you done? Atif?
Yes, sir.
Okay. Now, when we are going to compare in a group, then we have to look at the bond strength also. Okay, we have to look at the bond strength. So we know that if I compare the bond strength, then HF will be strongest, followed by HCl, followed by HBr, followed by HI. Right. So HI will have the least stable bond. Now let us see and try to tell about the stability of conjugate base. Yeah. So conjugate base, we have F negative, Cl negative, Br negative, and I negative. Okay, and I negative. Now, if I go top to bottom in a group, then the electronegativity is increasing, right? The chi is increasing, but no, sorry, chi is decreasing. My bad. The chi is decreasing, but there is another thing that is increasing. If I go from here to there, the size is increasing, right? The size is increasing. And hence I can say all of them have one negative charge, but fluorine will be like this, and chlorine will be like this, bromine will be like this, and iodine will be like this. That means the charge density, if I go from top to bottom, the Q density, the charge density is what? It is decreasing. And if the charge density is decreasing, that means our ions are more stable because we should have less charge density. The stability is inversely proportional to charge density. So if charge density is decreasing, stability will be increasing, right? So I negative will be most stable, Br negative will be then, and then chlorine negative and F negative. Okay. So whenever you are talking in terms of group, and there is a factor which there is something, for example, the stability of conjugate base, the size is a factor which affects, then size will dominate, not electronegativities, because there is a huge increase in size and there is not much increase in the electronegativities of the halogens when I go from top to bottom. So whenever you have a particular property in which size is a factor, then in groups, size is going to dominate. And hence I can say that the acidic strength here, the HF is the least acidic, followed by HCl, followed by HBr, followed by HI. So both of these things, bond strength and conjugate base stability, they are favoring this trend, because if HF is having a high bond strength, what does that mean? It means that H and F cannot be broken easily, comparable to HCl, HBr, and HI. Okay, so write this down. Then we can also write acidic strength. We can compare for what do we have? H2O, H2O, H2S, H2SE, H2TE. So in this case also, H2O will be least acidic, followed by H2S, followed by H2SE, followed by H2TE, because we are talking in terms of a group.
Answer.
Done, all of you? Yeah, guys, done? No, yes. Atif, done?
Yes.
Okay, right. Done? No. Okay. Now, till now we have done treatment of acids and bases, but we have only added one acid or one base. We have not added multiple acids on a single solution, or multiple base on a single solution, or a combination of acid and base, or a combination of acid and salt, right? We have not done these things. So let us try to understand what will happen. And this topic is under common ion effect. Common ion effect. है ना? So common means, so for something to be common, you should have at least two. है ना? You should have at least two. So this is when you have one species, then common ion effect will not be there. Okay, common ion effect, you will not have to consider common ion effect. Whenever you have two or more species that is added, you have two or more species that is added to a solution in water, then you are going to use this concept that we are going to learn in common ion effect. So right, this is useful when more than one chemical species is added to water. Okay, is added to water or solution. Now, so what I will do, I will start with a reaction. So please listen, don't write. Please listen, don't write. We have an acid and it gets dissociated into H positive plus A negative. H positive plus A negative. Now let us say I added some other HX molecule and it is going to give me H positive plus X negative. And I added another molecule, let us say that is MA. I added another molecule that is MA. Okay. So I'm going to get M positive and A negative. M positive plus A negative plus A negative. Okay. Now this is our original or primary reaction. This is our original or primary reaction. Original. Okay. Now all of you can see that if I'm adding HX, then H plus concentration is increasing. That means the human who is adding HX in the solution, which is HA giving H positive and A negative, human is adding H positive and concentration of H positive is increasing. That is why the system, it will shift the equilibrium towards forward or backward, guys. If I'm increasing the concentration of H positive, what will happen?
Backward.
Yeah. So if I'm this reaction, if you have this type of reaction and in which you have something similar from the product, then the equilibrium will shifts backward. Again, here also, if I'm adding something and it has the conjugate base which is common or one of these species from the product common, then again what is going to happen? Equilibrium shifts backward. Fine. So this is known as the common ion effect. So we can see that I am adding two things. So as that you are adding three things, you will be adding at most two things in this class, like in 11th class. Okay. So if you're adding two things, then you will have at least one thing which is common, and one of the ions will be common, and it will be affecting the original reaction. So please write this down. Let me know if you're done. Then we will look at a question.
Answer.
All of you done? Yes or no? Atif and others done?
Yes, sir.
Okay. So write a question. Okay, this is the same question that I wanted to do like earlier. So we can do this one now. Okay, and in this rather, okay, fine. So we are not doing this this one. This is also similar type of question, but rather we are going to do this question. Okay, the first ionization constant of H2S is 9.1 into 10 to the power minus 8. Okay, so write this question, all of you, first of all, then we will start doing this. Let me just reshare this thing. Done, all of you? Yes or no?
1 minute, sir.
Okay, okay.
Done, sir.
Okay, fine. So first of all, we will write this the H2S. Okay, so Ka1 is given as 9.1 into 10 to the power minus 8. So first thing is that weak acid or strong acid? Tell me, guys. Look at this number and tell me, strong acid or weak acid? What do you think? This is the first thing that you have to always understand. Okay, I think you know how to do, but आपको practice नहीं हुआ है बस. So Ka1 का मतलब क्या हुआ? Ka1 means concentration of H positive, concentration of SH negative divided by concentration of H2S. Look at this number, look at the ratio, and now tell me what is more, product is more or reactant is way more? Which is more? Look at this number 9 into 10 to the power minus 8 and tell me which is going to be higher, products or the reactant?
Products.
And
Why are you saying products, Atif? 9.1 है ना ये तो, so I can write this as Ka1. It is equal to इतनी आप लोग ना प्लीज ऐसे कर लिया कीजिए हमेशा. I don't want all of you to get hanging like this. So 10 to the power minus 8 I can write it as yes or no, Atif? ये बताइए आप.
Yes, sir.
अब बताइए what is more, product is more or reactant is more? नहीं आ रहा, अभी भी नहीं आ रहा.
Yes, sir. Reactant is more reactant.
Reactant,
I said product by mistake.
अच्छा. So this is the first thing, all of you. Okay, so whenever you get K ना, तो थोड़ा दिमाग में एक बार बस like get a thought of it, है ना? You just think about it, whether it is going to be strong acid or strong base, because it is going to be useful, है ना? It is going to be useful. You know that there are cases, different cases are there for strong acids and strong bases, and for weak acids, strong acid and weak bases. Okay, so we can write weak acid. Okay, weak acid. So I will write initial, change, and at equilibrium. So initial is H2S is how much? So they are given 0.1 molar, right? Concentration of H2S 0.1 molar, and this is nothing, and this is nothing. Change is how much? The change I will write it as minus X, and this will be plus X, and this will be plus X. So this will be at equilibrium 0.1 minus X, right? And this will be plus X, and this will be plus X, plus X. Since it is a weak acid, a very small quantity of H2S will be getting dissociated, right? Yes or no? Tell me. A very
Yes,
small
sir.
quantity. That means, see, this is the thing. This is how things become easier if you know what is weak acid and what is strong. Okay. So Atif, you just mentioned that since X is going to be very small because it is a weak acid, very less number of and very less fraction of the H2S acid will be getting dissociated. So I can write that X will be very, very less than 0.1. And hence, if I subtract 0.1 with something which is very, 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 very less, then I can just write it is somewhere equal to 0.1 only. But I cannot write that this is equal to 0. Okay, please remember that, because there is nothing to compare here. we have here, we can compare 0.1 and x. That is why I'm just writing 0.1, because if I subtract something very small from 0.1, it is not going to affect anything. Fine. Now you can write down Ka. You can write now Ka, which will be equal to the concentration of H positive into the concentration of SH negative, right, upon 0.1. Correct? Yes or no, guys?
Yes, sir.
And this will be, what is Ka? So we can write Ka, it is equal to how much? They have given Ka, 9.1 into 10 to the power minus 8. So this will be equal to 9.1 into 10 to the power minus 8. And H plus is also x. SH negative is also x. So this will be x square divided by 0.1. Divided by 0.1. So this will be equal to x square. That is equal to 9.1 into 10 to the power minus 8 into 0.1. That means 1 upon 10. That means 10 to the power minus 1. है ना? कर लीजिए आप, है ना? Can you calculate x here now? 9.1 into 10 to the power minus 9. Yes or no?
Yes, sir.
So x will be equal to root of 9.1 into 10 to the power minus 9. So root of 9.1 into this will be how much? Okay, 9.5. This will be 10 to the power minus 4.5. Correct, guys? Yes or no? Any problem? No problem, right? Okay. So this is under root 9.1. I hope all of you know how to calculate 10 to the power minus something. Correct? So you can write as I can write minus 4.5 as 10 to the power 0.5 into 10 to the power minus 5. बताइए. We have done this now, log में.
Yes, sir.
Yes.
Right? Okay. And we also know under root 9.1 into 10 to the power minus, 10 to the power 0.5, it is equal to how much? Log 3. So 3. 10 to the power 0.5, it is equal to 3 into 10 to the power minus 5. Yes or no? Tell me, guys.
Yes, sir.
Yes, sir.
चलिए, तो अब 9.1 का हमको देखना है ना. So we have now root 9.1 under root 9.1. So I can write this as under root of 91 upon 10, or I can also write this as under root of, if I multiply 10 here and 10 here, if I multiply both things by 10, this will be 910, right, divided by 100. So I can write this as under root of 910 divided by 10. Correct? Yes or no? Tell me.
Yes.
So now it will be easier to approximate the square root of 910. Now you can do some hit and trial. So 910, what do you guys think? It will be near to what? 30, na? Yes or no?
Yes.
Yeah, 30. So what should we do? 13 to 30? 13 to 30, 31 to 31. 31, and then here you will be getting 3, and it is a 9. It is going to be very high. That means it will be equal to 9 point something. Sorry, 31, 30 point something. 30 point something.
Sir, 30.1.
30.1.
Yes, sir. 30.1 is close.
It's close. Okay, fine. So 30.1 divided by 10 into 3 into 10 to the power minus 5. So yeah. So this will be, wait a second. Actually, can I write here? This has 3.1 because log 3 is 0.48, na? Yes or no? Right, guys? So because we are approximating quite a lot, that is why I want to just, we can obviously write 3.1 here, because if you try to find the log of 3.1, I think it will be near 0.5. 3.1, that means for 32, log of 32, if I find log of 32, then this will be how much? 32 means 8 4s, so 2 to the power of 3 into 2 to the power of 4, so 2 to the power of 5. So 5 into 0.3. क्या रहा? It was a 32, no? Wait. Where am I being wrong? Acha, fair. Let us keep this as 3.1. So we have, can you calculate this and tell me what is the answer? 3.1 into so it'll be somewhere around 93. 3 into 10 to the power minus 4. So we can write this as 9.33 into 10 to the power minus 4. This is the x that we are getting. Minus 5 हो जाएगा यहाँ पे, sorry, because 9.33. Done, guys? So this is the x we have got. Okay, this is the x that we have got. That is the concentration of H positive. Right? That was the, yeah, that is the concentration of H positive. When we don't have any HCl. Okay, here we don't have any HCl. We have not. So what is will be the first time calculate the concentration of SH negative. SH negative will also be equal to this much only. And the concentration of SH negative will also be equal to X, which is equal to 9.33 into 10 to the power minus 5. Okay. You write this down. So this is when we done now. Okay, fine. So this is when we don't have any HCl. When we don't have any HCl. Now let us suppose what happens. What you have to calculate. How will this concentration be affected? So I'm trying till here. Okay, trying till here. How will be this concentration affected if the solution is 0.1 molar in HCl also? So in the presence of HCl, now we have two reactions happening. We have reaction that is H2S. It is giving me H plus SH negative, and then we have HCl also. It is also giving me H plus and Cl negative, H plus and Cl negative. So from here, H2S I am getting how much? 9.33 into 10 to the power minus 5. Okay, from HCl I will be getting the whole amount because you can see the concentration is very high. The concentration is 0.1. That means completely 0.1 molar HCl I will be getting, and it is a strong acid, right? HCl is a strong acid, so this will be 0.1, and hence from H plus also I will be getting 0.1 molar. Yes or no? From both of these things?
Yes.
Tell me, guys. Right? So we will be getting it. Acha. Now the next thing is that I know that the Ka now for H2S, it is no matter what you have done, this ratio of H plus in the solution. Like when you have H plus in the solution, then H2S does not know now whether it is coming from H positive or whether it is coming from HCl or it is coming from H2S. So in the solution, you have H plus and the concentration of SH negative divided by the concentration of H2S. It should be constant no matter whatever you are adding. No matter whatever you are adding, the Ka should be constant. The Ka should be constant. Now, but here we have added some H positive ions, right? We have added some H positive ions. Now, if I added some H positive ions, some of these H positive of H2S, it will be getting reacted and it will be getting converted into H2S. It will be getting converted into H2S. Yes or no, guys? Tell me.
Yes, sir.
Right. Okay. Now, so what does that mean? First thing is that I can say that the current H plus total, it should be equal to the concentration of H plus from H2S plus the concentration of H plus from HCl. Yes or no? So I will try to find all of these things. I will try to find all of these things. Okay. I've told that H plus total will be equal to the H plus that is coming from H2S and then the H plus that is coming from HCl also. But I can see that the concentration of H plus from H2S, it is going to be very, very small than the concentration of H plus from HCl. And here is 10 to the power minus 5 hai, and this is 0.1. That means 10 to the power minus 1. So you have 0.1 and I'm adding this 0.000093. So it doesn't make sense, right? So I can directly write the concentration of H plus total. This will be equal to 0.1 molar. Okay. Any problem till here? Tell me that.
No.
No problem,
No.
right? No problem. Okay. Now, let us also see. What will be the concentration of H2S? I know what is they have given the concentration of H2S. I know they have given the concentration of H2S. We have H plus concentration, so I will write Ka equal to concentration of H plus into the concentration of SH negative. I don't know how SH negative is affected, how SH negative is affected, and then we have H2S, and they have given this as how much? They have given this as 9.1 into 10 to the power minus 8. 9.1 into 10 to the power minus 8. Now, H plus is 0.1 into concentration of SH negative, the new SH negative, okay, after we have added HCl, by the concentration of H2S. So what is the concentration of H2S? H2S is 0.1, right? Yeah. H2S is 0.1 that they have given. 0.1. This will be equal to 9.1 into 10 to the power minus 8, right? So you can see that the concentration of SH negative is how much? 0.1 and 0.1 can get cancelled. And this will be equal to 9.1 into 10 to the power minus 8. This is the concentration of SH negative after addition of, it is important that how much HCl is added. Addition of 0.1 molar HCl. And before was how much? Before the concentration was, what did we calculate? 9.33 into 10 to the power minus 5. 9.33 into 10 to the power minus 5. And so you can see that when I'm adding HCl, what is happening? The reaction is shifting backwards, and that is why the concentration of SH negative is decreasing to maintain this Ka. Okay. So write this down. Let me know if you're done.
Done, sir.
All of you done? Yes or no? Done? Done, guys? Atif and others?
Yes.
Done. Okay, fine. Chalo. Thank you very much. We will meet on Wednesday. So come with some doubts. Maybe we'll see if I can send you a sign, because we have not covered many long topics today or calculation topics, some simple questions, and whatever I have taught today, like pH and pOH, K, Kb, and then acidic strength. So these questions will be inside, and also common ion effect. All of these questions will be inside some big questions. Okay, there will be no separate questions such as you have to try to calculate the K or Kb. They will be inside some different questions. Okay, so we will meet on Wednesday. bring some doubts. There are two topics that is left here. The one is salt hydrolysis. The next is buffer. I think salt hydrolysis is removed from your syllabus, but we will just hover around it. And then we also have solubility product. Yeah, solubility product is there. Buffer is also almost removed because they have removed the Anderson-Hasselbalch equation. And then we have the hydrolysis, which is also completely removed. Here, we will see about those things, and also